Okay, in this section, what we want to do is to integrate expressions of square root with squares inside. Okay, so often these are very hard to integrate directly. It's the square root that makes things difficult, okay, with two terms inside. So we can get rid of these square roots by making the proper trig substitution. Okay, first case, when you have a squared, subtract by a variable square. So it's a constant and a variable. The correct substitution is to let x be a sine of theta. And the reason is because we want to turn these two terms, okay, we want to turn the two terms into one term, right? Some product, right? So that we can get rid of the square root, right? So keep in mind that this does not equal to a minus x, right? Only if you have a product of a and x, we can replace that with just a and x, okay? So some students sometimes mix this rule with the sum rule, and you cannot go from this step to this step when there's two terms, okay? So for that reason, we need to make the proper choice so that we can turn it into a product. So let's think about why this is the good choice. Why x equals a sine of theta is a good choice, right? So we have a squared minus x squared. If you replace x with a sine squared theta, okay? So x squared with a squared sine squared theta, because that's what you get when you square x, which is a sine of theta. You factor out a squared and you get this. Okay. This is the correct choice because this will turn into a single term squared. Okay. So it's all about turning the two terms into a single term like this so that we can get rid of the square root expression and get a simple expression of a cosine of theta, which we can easily integrate. Okay, the reasoning is the same for why this the second case scenario here, why x needs to be replaced with a tangent of theta. Okay, it's because we know that 1 plus tangent squared theta is going to turn into a single term squared. Okay, so if you replace x with this, right? So let me do that here. A squared plus x squared. X is a tangent of theta squared. If you factor out the a squared, look, you get 1 plus tangent squared theta, and right, that will turn into secant squared theta. Again, it can just be expressed without the square roots, a times secant of theta. Okay, so that's great. Same thing is going to happen with the last one. Okay, so I suggest you plug it in and go through it. Okay, so it's actually, it's our knowledge of these three trig identities that allow us to do this, and the fact that we don't want square roots, we want to get rid of it. Okay, so let's do some examples and clarify and strengthen this idea and technique.